All right, yesterday we talked about the classification of matter, what matter is, and how we divide it up. Today we're going to discuss properties and changes. So what are these things that we're going to talk about? In fact, this is actually what chemistry is all about. The easy definition of chemistry is the study of matter and the changes that it undergoes. So in order to understand these changes, we also have to understand these things called properties. So let's get going on that. Properties of matter. Substances, chemical or elements and compounds, can be described by their physical characteristics as well as their chemical reactivity, what they do. So their physical characteristics are things that we can observe with our senses. These are called properties. So you've got physical and chemical properties. Properties are what things do, or how they behave, how we observe them, how we describe them. All right, so physical properties is the first time we're going to talk about. Physical properties are characteristics that describe the physical nature of a substance. So they are observed or measured using our senses. So we can look at something, we can smell something, we can hear something, we can taste it, we can feel it. The physical properties, how we describe it using our senses, those are our physical properties. So examples, the size of something. I can look at a brick or a rock and I can tell you it's big or it's small. I can actually measure it, so I can give a quantitative measurement of its actual dimensions, or I could give a qualitative measurement of its relative size. But size is a physical property, right? The shape of something, whether it's square, cube, triangle, rectangle, misshapen, or odd shaped, the shape is a physical property. I observe it with my eyes, or I could feel the shape of it with my hands, but it is a physical property. Color, like my shirt is blue. You look at this and you see that it is blue, so that is a physical property. It's something that we observe. All right. The state of matter, that is a physical property. So whether something is a solid, liquid, or gas, water, ice, or steam, those are all water. They're all H2O. Whether it's ice, liquid, water, or steam, it's all H2O. They're all the same thing. The state of matter is a physical property. It's a physical characteristic. So let's talk about these states of matter. There are 3 states of matter that occur on Earth. 4 if you really want to get technical. We're not going to talk about plasma in this class, but there are 3 that you really need to know about. We have solid, liquid, and gas, and this is all mostly stuff that you probably learned in earlier grades, and you know that things are either solid, liquid, or gas. So we're going to talk about them fairly briefly. Solids are the lowest energy state of matter, which the particles and substances are closely packed together and they just vibrate in place. When I say the lowest energy state of matter, that does not mean all solids are lower energy than all liquids, but of a given substance. So when I'm talking about, say, water, H2O, solid water, or what we call ice, solid H2O is a lower energy than liquid H2O. It is the lowest energy state. All right, solids are not compressible, which means if I have a solid, I can't push on it and make it squish down. Okay, if I have a pure solid, it is incompressible, cannot be compressed, and they maintain their shape and volume. So a solid is going to keep its shape as long as it is a solid. It will stay the shape that it is, and it will keep its volume. So like the table that your computer is sitting on right now, it is a solid. It is most likely rectangle or circle, depending on where you're sitting, but it has a shape, it has a size, it has a volume, and it is going to maintain that, and you cannot compress it because it is a solid. So here's a little picture of what that looks like. So the particles are still moving, they're just moving really in place. They're just kind of vibrating in place and not really moving around. They have a specific arrangement of the particles and they stay in that arrangement. That's why they keep their shape and their volume, right? Because the particles, the atoms and molecules that make up the solid just kind of sit there and vibrate in place. That's a solid. Then we have liquid. Liquid is the middle energy state of matter, which particles of the substance are moving in a way that they slide past each other. So they're moving a little bit more than in a solid, or a lot more than in a solid, but not quite as much as in the gas state. So liquid water, the molecules are moving more than they are in ice, and they slide around and slide past each other, but they're still relatively close to each other. You think of it kind of like a mosh pit. Where people are bouncing around, moving around, but they're still relatively close and touching each other. So liquids are also not compressible or incompressible, and they maintain their volume, but will take the shape of their container. So if I have a container of this, let's say this is, I don't know, 100 milliliters. If I have 100 milliliters of this liquid and I pour it into a different container, it's going to maintain its 100 milliliters of volume. If I pour the whole thing into it, but right now in this flask, it's got this shape that is the shape of the flask. If I were to pour it into a beaker, then it would take the shape of that beaker. Or if I would pour it on the table, it would just spread out all over the surface of the table, but it would maintain its volume of 100 milliliters. So they take the shape of whatever container they're in. If they don't have a container, they just spread out, but they keep their volume. Their volume does not change. So when you look at the particles, notice they're moving a lot more than they are in a solid, and they are able to move and slide around past each other. They don't stay in the same configuration. If I were to tilt this, they would move and pour like a liquid does. So that's a liquid. Gases are the highest energy state, in which particles of the substance move quickly and randomly. So they move around and they don't really have a specified direction. Oftentimes they don't even come into contact with each other. So you could feasibly have a sample of a gas where particles of the gas never actually touch each other. They just fly around past each other and they don't actually come into contact because they're all highly spread out. So when we say it's the highest energy, it's again for that substance. So using H2O again, water, ice, liquid water, and steam. Ice has the lowest energy, liquid water has the middle energy because it's a liquid, and steam, being a gas, is going to be the highest energy. And we often will translate that energy of the particles into its temperature. So you should recognize that ice has a lower temperature than water, which has a lower temperature than steam, because the energy of the particles is directly related to the temperature of the sample. So gases are compressible. That's why you can have an air compressor. So it means you can take a gas that is in this volume and you can squish it down. So let's say I had a balloon and I blow the balloon up. I can then squish the balloon into a smaller container. Gases are compressible and they will change their volume and shape to match the volume and shape of their container. If I were to take some perfume and spray it in one little corner of the room, you would hear that or smell that perfume eventually throughout the entire room, because the gas of that perfume, as it flies through the air, it will spread out and fill the container, even if the room is fairly large. Now you won't be able to smell it as much once it fills the entire room because it's very dispersed, but it will fill the container, and it will match the volume and shape of the container that it is in. So if I have a 5 milliliter container filled with a gas, and then I take that gas and I open up that container and I release it into a 5 liter container, that gas will go from 5 milliliters to 5 liters. It will fill the volume of the container. So this is what particles of gas look like. They kind of move all over the place, and they're fairly spread out. So you've seen the solid, liquid, and gas. Now again, make sure you understand that these are physical characteristics. They're physical properties. So the state of matter, whether it's a gas, a solid, a liquid, the physical state of matter is a physical property. Chemical properties, again, physical properties are things that you can observe with your senses and describe what it is. Chemical properties are characteristics that describe how it reacts with other substances. So physical properties describe what it is. Chemical properties describe how it behaves. Okay, what it does. So iron is a metal, and we know that iron combines with oxygen to form rust. That's why iron rust, it forms something called iron oxide. So iron combines with oxygen to rust. It's telling us what iron does, how it reacts with oxygen. This is a chemical property. A chemical property of iron is that it will react with oxygen. It oxidizes. All right. Gasoline is combustible. Combustible means that it will produce fire, basically. Not necessarily explode. Yes, gasoline can explode, but combustible does not mean explode. It's more producing a combustion reaction of fire. So gasoline is combustible. That's something gasoline is. It's something it does. It combusts. So combustibility is a chemical property. It's describing how it reacts with something else. Right? Sodium, a metal, reacts violently with water. So it's telling us how it reacts. Sodium will combine with the oxygen and the hydrogen in the water, and it produces a really cool thing. I'll show you that at some point when we're talking about a different type of reaction. I will show you this reaction. It's really cool. But sodium reacts violently with water. These are chemical properties. Notice the physical properties were just, again, describing what it is. It is blue, it is big, it is small, it is square, it is solid. Or physical properties describe what it is. Chemical properties describe what it does, how it behaves. Okay? So once you understand chemical and physical properties, we can talk about these changes in matter. When a physical property changes, but it does not change the substance, we have what's called a physical change. A physical change has taken place. So taking a piece of paper that's a rectangle and crumbling it up into a ball, that is a physical change. I didn't change what it was. It's still paper. I just changed its size and its shape. Okay? So if I tear the piece of paper, again, I didn't change what it was. It's still paper. So if I change the state of matter is a physical property. So changing a physical property but not changing what it is a physical change. So ice is a solid. If I melt that ice into a liquid, it is still H2O. Ice is H2O, water. It's just solid water. If I melt it, it's still water. If I boil it into steam, it's still water. So I didn't change what it was, I just changed its physical property. So changing a physical property without changing what it is a physical change. So melting, freezing, boiling, condensing, evaporating, those are all physical changes because you're not changing what the substance is, you're just changing its physical property. When a change occurs that does change the substance, we have a chemical change has taken place. So when I take iron and I put it in water, that iron will react with the oxygen in the water and it forms iron oxide. Iron is, once it rusts, it is no longer iron. It has changed into rust, and therefore it has changed what it was. It's no longer the same thing. So I can't take the water away and get my iron back, right? If I bake a cake, you mix all the ingredients together, and they're a nice, lovely mixture. You could probably separate them out. Yeah, at that point, when it's just the batter, it would be really difficult. But once you cook it, once you apply that heat and it cooks, a chemical change happens, and you now have a cake instead of batter, and that cake is different than the batter, and you can't go back. You have actually changed what it was. You didn't just change it from a liquid to a solid, you changed what it was by cooking it. The heat caused the chemical reaction to happen, and you have a chemical change. So if you're not sure if it's a chemical change or a physical change, ask yourself, does what it is change from before to after, right? If it is water before and it's water after, then it was a physical change. If it's a metal before and it's a something else after, then it changed. It would be a chemical change. So did the substance change? If the substance changed, it is a chemical change. If the substance did not change, its characteristics just changed, then it's a physical change. So hopefully that makes sense, and you can continue on with your assignment and make sure that you ask questions if you have them.